Hey class, today we're going to do the iodide clock reaction, the vitamin C edition. So to start off, I just kind of want to read to you some notes I made about the purpose of this experiment. So the purpose is for the rate law for the reaction of the iodide clock reaction is to be established. We want to establish like the rate of that reaction, how it happens, and why it happens. It involves the determination of the order of reaction with respect to each of two reactants, as well as the determination of the rate constant for a particular solution. So here in this experiment, we're looking at two different solutions that have been created. For the sake of this video, I already made the solutions. It took a bit of time, a little bit longer than 5-10 minutes. So I figured that I would make it myself and then start the video. So I have my two solutions here, and I'm going to talk about a little bit about how I made them. This one is the vitamin C solution, and this one is the peroxide starch solution. Oh, this one also has the iodine in it. So to make the vitamin C solution, I first crushed up, these are 500 milligram tablets with what they say is natural rose hips. It's just something floral in the tablets. It's all I could find. So what I did was I put 2,500 milligrams crushed into a cup. It recommended 2,000, but because there was an extra filler in here, I figured I would add a little bit more of the vitamin C to this solution. And then crushed it up, stirred it up with distilled water. I drained that so that I had a clearer solution of the vitamin C. And then I added 30 milliliters of iodine tincture solution. This is a 2% iodine, so they suggested 5%. They didn't have that at the store, so we're going to see how this works with the 2%. It's likely that it will take longer, the solution will take longer to turn blue or a dark color, but we'll see what happens. So that was that, and I mixed that up. This is kind of what it came out to be. It's not quite clear. That's partially contributed to the fact that the vitamin C tablets, they weren't white to begin with. They were like a pinky orangey, so this would make sense. For the starch peroxide solution, I started out by adding the 0.4 grams of starch mixed with 350 milliliters of distilled water, mixed it up, heated it up, and strained it in a strainer and a coffee filter. And then I put 150 mils of hydrogen peroxide in here, and this is what it came out to looking like. As you can see, it's still a little cloudy, kind of like the video, not perfectly clear. Again, there's always going to be error when you're doing an experiment outside of a lab, and even when you're doing an experiment inside of a lab, there can be an error. So here, we're just kind of looking at the solution here. So I am going to kind of talk about what we're going to be looking at. What I'm going to do is I'm going to take a cup and we're going to mix half of the vitamin C iodine solution and half of the peroxide starch solution and wait to see how long it takes to change colors. And what we're dealing with here is I wrote out what was in the initial video onto a piece of paper just so I could talk about it. So the hydrogen peroxide in the solution wants to oxidize the I negative back to colored I2. And the absorbic acid, the vitamin C, wants to reduce it from I2 back to I negative. So, or I minus, that would be the proper way to say it. I2 is not going to exist for very long. It's transient. And the vitamin C will end up running out. So once the vitamin C runs out, and this is when we're going to start to see a color change, because what's happening is it's a reaction that's going back and forth. The peroxide wants to oxidize the I minus back to I2, and the absorbic acid wants to reduce it from I2 back to I minus. And so we're just going back and forth, and you're not going to see a color change. But when the vitamin C runs out, I2 is then going to form with I minus to form a triiodide. And from there, moving my finger the wrong way. From there, it's going to react with the starch to form the blue iodine starch complex. So hopefully that's what we're going to see. If we don't, I've just explained to you what we should see, and we'll take it as, you know, lab error, considering I'm in a kitchen and not in a lab, not with official lab scales. I use my food scale. It doesn't even weigh milliliters and doesn't go beneath a gram. So if it doesn't work, we'll take it as for what it is. But this is how it is supposed to work. So I'm interested to see how long it's going to take to change colors. So I'm just going to get out my timer here and I'm going to get ready to start the clock. So we're going to mix up a little bit of the starch peroxide solution. We're going to do about half and half. And then I'm going to do a little bit of the vitamin C solution. Fill it up to about here. And I am starting my clock. Let me get it so that I can hold it up for the camera. And I'm just going to have to wait to see a reaction. So right now, like I said, what's happening is the hydrogen peroxide in this solution is oxidizing the I- back to colored I2, but the absorbic acid is reducing the I2 back to I-. So we're not seeing any color change yet. I certainly hope that we do. I even went back to the store to buy the right vitamin C drops. Like initially I bought those vitamin C like cough drops, the candy ones. I didn't realize that was the wrong thing. Whoops. Come on, I made 2 trips. Please change colors. So one thing to note here is that the color change may take longer if there's more vitamin C, and because there's 25 milligrams of 2,500 milligrams of vitamin C in here, and there was like a smaller percentage of iodine, it's likely that we're just going to see this take longer to change color. I think we might be seeing a color change now. Yeah, because it's going to take longer with more vitamin C. It would be faster with more iodine, but remember, I only used a 2% iodine instead of a 5% iodine. And another thing to note is if the temperature of this was higher, then it would have a quicker reaction rate. This is pretty cool, so it's likely that the reaction isn't going to be too fast. We're coming up on 2 minutes though, so I'm wondering if there was some sort of error. But I'm going to just let this run until 10 minutes, which is the time limit for the video, and we'll see what happens. While we're waiting for that to change colors, I'll just show you the ingredients that I used. This was the hydrogen peroxide that I used. Cornstarch that I used, vitamin C tablets that I used, and the iodine. I added a little bit more iodine to the solution. Let's try to see what happens if we stir it up. Whoa! Super cool. So what I didn't realize is in adding half of the vitamin C solution and a half of the iodine solution, I was actually creating a really big imbalance of vitamin C just because I added extra vitamin C, and by nature I added less iodine because it was a 2% solution and not a 5% solution. So I just added the rest of the iodine solution in here so that it would kind of balance out the extra vitamin C. And here we saw a color change. Look, right now it kind of looks to be a little bit greenish, a little bit brown. I think if we let it sit a bit longer, it would look like Coke. So anyways, because of the imbalance, it took about 3 minutes to change. Again, with extra vitamin C, it takes longer for the reaction to occur. With more iodine, it goes quicker. Thanks for watching.